Good afternoon, the conference organizers. Good afternoon, my fellow participants. My name is Chibuike Peter. I'm here with Ifeanyi B, Cajethan, and Umeogamba Anthony I. We are here today to present a paper titled Electrical Power Loss Reduction on Rural Distribution Network in Nigeria, a case study of Aku-Nsukka feeder. My presentation outline is as follows. I will start with the background of study, then look at the statement of problem, look at the aim and objective of study, followed with the significance of study, the methodology, results and discussion, and finally we look at the conclusion. Background of study. Nigerian distribution network has saddled with the challenges of low voltage profile and high power losses. These occur due to the inappropriate settings of the distribution network. For instance, the Nigerian grid network has faced numerous collapse challenges for the past 2 years. This happens due to lack of planning by the utility network providers and so on. Now, the electric power systems, which include a group of switchgears, lines up including circuit breakers, isolators, collectors, switches, are each coupled to one or more loads. These distribution systems or networks are faced with the challenges of power losses, and these losses cannot be totally eliminated, but with the help of new technologies and techniques or methods introduced, it can be minimized to its barest minimum by proper planning. The network losses can be divided into two categories. They are technical losses and non-technical losses. The technical losses are the real and the reactive power losses that occur in the network. These losses occur due to the opposition to the flow of current, thereby heating up the conductors, which generates heat and marginal losses to the network. Where the reactive power losses occur due to the presence of reactive components in the network, they tend to absorb reactive powers, thereby exposing the network to its critical condition. The non-technical type of losses are those losses that are commercial losses, which are being caused by the providers due to inappropriate meter reading or billing system. With this, they incur losses to the distribution network. Statement of problem. The Nigerian distribution network has a great problem of inadequate power supply. These occur due to power losses and voltage drops along the line, and these voltage drops are due to overloading of the substations most times. So every distribution network has several elements in power system that resist power flow and consumes a lot of energy, while granting access to free flow of current through it. That of Nigerian distribution network has same problem too. The problem of losses and voltage drop in these distribution feeders are dependent of another, but varies with the pattern of loading on the feeders. The total power generated from the generating end will not reach the end users always, since fraction of power losses is lost as losses. In these circumstances, there is a need to develop a new and intelligent tool which will be easy to implement to efficiently approach and tackle these problems. Because when these problems are being tackled, we intend to have an improved power supply. Aim and objective of study. The aim of this study is focused on the power loss reduction on distribution network through a specific method, which is regular maintenance of the distribution network components and a replacement of deteriorating 1 out of 40 distribution components. But before this, our case study has some specific objectives which we need to tackle. 1. We need to look at the existing state of our Aku-Nsukka distribution network. We then identify the areas where there are worn-out distribution components for proper maintenance and repair. Finally, we now capture the power factor at various substations before and after maintenance of a possible power factor correction. This will help us to see the improvement in the power factor before we conclude that our method applied works efficiently. Significance of study. This work tends to benefit the following people, but they are not limited to these people. 1. The electric utility companies and the government. Results of this study will be of great importance to them because the system stability will be maintained. Thus, financial burden on the network will also be minimized. Secondly, the domestic and the commercial consumers of electricity, especially those in our case study area, which are the Aku-Nsukka dwellers, they will benefit from the study greatly because their loads will perform efficiency as a result of available and reliable power supply. Finally, the results obtained from the work will help students and researchers too to carry out their own work in the area of power loss reduction. Methods of reducing electrical power losses. Before now, there has been in existence several methods used to reduce electrical power losses on distribution network. They include 1. Proper use of jointing techniques and setting the numbers of the joints to minimum. In this method, researchers tend to reduce or minimize the number of joints in the network. By then, they tend to achieve an improved electricity supply with less power losses and improve voltage profile. The second method is selection of the proper conductor size as well as the transformers in terms of efficiency, size, and location. In this method, the researchers use the accurate and the actual size of conductor which can withstand the amount of current that is being passed through it. They also look at the load assessment of area in which they want to electrify by bringing out the required rating of transformer that can withstand this amount of load. The third method is the inspection of connections, isolators, dropout fuses, low tension switches, transformers, transformer bushing system, and other distribution equipment regularly. The fourth method is the direct feeding of heavy consumers from the feeders. Yes, there are consumers that consume more electricity or more power than others. For instance, the hotels, some mini industries that are located along the distribution feeders are normally fed direct from the injection substation in order to stabilize the power supply. Another method is proper load balancing and load management. When loads are well organized, balanced, and distributed, we tend to achieve improved full power delivery and voltage profile. The last method we looked at is achieving an improved power factor by adding shunt capacitor. When shunt capacitors are being integrated into the distribution network, they tend to introduce a very high power factor correction. In their method, they inject reactive power into the network. These reactive powers tend to compensate our reactive components in the network. Methodology. With the official permission from Enugu Electricity Distribution Company, the size of the 8 distribution feeders we have visited for data collection. Their data we analyzed for 2 years, starting from 2016 to 2018 using MATLAB Simulink software. Table 1 shows us the average power factor on the 8 distribution feeders considered in this work. These 11 kV feeders are Aku-Nsukka, Urute, Enugu Olivet, Oguru Road, Edemani feeder, and finally the Enugu feeder. The power factor as at March 2017 we are tabulated starting from that of Aku, which is number 1, to the number 8, which is 0.86. The same thing was done at March 2018. The comparison has shown a great improvement in performance of these power factors after much maintenance work has been carried out on the distribution network, we achieved an improvement in power factor. In fact, the power factors were actually corrected. For us to achieve this, we made use of the mathematical modeling equations. Like equation 1 helps us to get derive the active power loss in the network. Equation 2 provided us with the reactive power loss equation. Power factor corrections we achieved using equation 3 and 4, where the kVA is regarded as a complex power of the substations, where kW is our real or active power. Data analysis of Aku-Nsukka distribution feeder. This shown model is a single line diagram of our case study, modeled in MATLAB Simulink software. It is an 11 kV feed distribution network containing 20 buses. These 20 buses shows the actual location and the point of each substations along the distribution. Results and discussions. From data analysis, the following results were obtained. A table 2, as shown, provided us with a cumulative percentage loss on each feeder. The 11 kV rural feeders starting from January 2016 to March 2018 has shown the varieties of a percentage loss reduction on the feeder. Simulation results. After much simulation and analysis has been done on Aku-Nsukka distribution feeder, we were able to develop figure 2, which shows the distribution feeder's power factor assessment. It has shown that Aku-Nsukka feeder had a great improvement after maintenance and the replacement of the worn-out components. Likewise, other feeders in the network from March 2017 to March 2018 are shown in figure 2. Then power loss reduction was also achieved using figure 3. Here we had a great power loss drop from 12% down to 6% during 2016 to 2017, which is regarded as one financial year. Then the analysis has shown that the average power factor recorded on Aku-Nsukka feeder from 2016 to 2017 is 0.82, and the power factor recorded from 2017 to 2018 is 0.89. The figure 1, as we have been seeing in our previous slides, compares these two power factors for 2 years. This shows an improved power factor from 2017 to 2018 after much maintenance work has been done. Also, the average voltage regulation for this same year is found to be 5.5%. We also observe that the percentage cumulative losses is low in almost all the feeders. We then recommended that appropriate selection of the suitable transformer in order to reduce the losses to a permissible limit is needed. All distribution transformers should have meters installed on them. This will enhance accurate calculation of power loss recorded in distribution network. Integration of shunt capacitors and FAR devices are very important. Distributed generations and smart grid systems implementation on the network is of great importance. In conclusion, we have proposed a method to minimize losses that occur in a distribution network. This is a novel method which is regular maintenance and repair of worn-out or faulty electrical distribution network components. It is very cost-effective in power loss reduction and voltage profile improvement when compared with the other losses. Other losses can be systematically reduced by proper selection of right and base feed transformers, feeders, setting the shunt capacitor in the right places. But when considered with our proposed method, you can see a great difference in cost. That's why we choose our method to be cost effective. Sequentially, Enugu Electricity Distribution Company should be well equipped also and be ready to invest into areas with little or no electric power supply in order to secure a bright future for the society through adequate supply of electricity. Thank you so much for listening.